3 years ago, an AI model shocked researchers by solving problems it was never trained to solve. No new data, no new instructions, just more scale, and suddenly, it could reason. That moment changed everything, because modern AI does not improve the way software normally improves. Engineers are not adding abilities one by one. Instead, they make models bigger. More data, more parameters, more compute, and then they wait. And sometimes nothing happens, but sometimes something impossible appears. Language models start writing code. Image models understand geometry. Robots learn balance without equations. No upgrades installed. No features unlocked. Just emergence. Inside these networks are billions of tiny numerical adjustments called weights. Each one is meaningless alone, but together they form vast probability landscapes, mathematical terrains shaped by experience. When those landscapes become complex enough, they begin representing patterns that look like concepts, not programmed knowledge, discovered structure. Researchers call this phase transition behavior. Like water becoming ice, intelligence can suddenly crystallize when scale crosses invisible thresholds. But here is the unsettling part. We do not know where those thresholds are, or what abilities appear next, or why specific capabilities emerge at all. We are scaling systems we cannot fully predict, training minds we cannot inspect, and deploying tools that may be reorganizing knowledge itself. Right now, every major technology company is racing to scale these systems faster than ever before. Each increase in size is an experiment with unknown consequences. We are not just building tools, we are probing the mathematical boundary where pattern becomes thought, and where prediction becomes something disturbingly close to awareness itself, and we still do not know what emerges. So the real question is not whether AI understands the world. It is whether understanding is just what prediction looks like from the inside. But let's go deeper, because what we're witnessing isn't just technological progress, it's something fundamentally different. Think about how we've built technology for thousands of years. We design, we engineer, we understand every component, every connection, every cause and effect. But AI emergence breaks that pattern entirely. When GPT-3 suddenly started doing arithmetic without being taught math, researchers were stunned. The model had only seen text, numbers as words. Yet somehow, buried in billions of parameters, it discovered the structure of mathematics itself. When image models began understanding three-dimensional space from flat pictures, that wasn't programmed. When language models started reasoning about physics, chemistry, and biology, those capabilities weren't installed. They emerged. And here's what makes this truly unprecedented. We can't reverse engineer these abilities. We can open the model. We can see every weight, every connection, every mathematical operation, but we still can't explain why specific capabilities appear. It's like discovering a new organ in the human body, except we built the body ourselves, and we still don't know what the organ does or why it formed. This creates a profound problem, because if we don't understand how abilities emerge, we can't predict what emerges next. Let me give you a concrete example of how strange this really is. In 2022, researchers at Google discovered something bizarre. They asked their language model to solve a logic puzzle that required multiple steps of reasoning, the kind of problem that would typically require explicit programming of each logical step. The model solved it, but when they examined how, they found something unsettling. The solution didn't follow any recognizable algorithm. Instead, the model had developed its own internal reasoning process, a process that worked, but that no human designed or fully understands. This is emergence in action, and it's happening everywhere in AI now. DeepMind's AlphaFold didn't just predict protein structures. It discovered fundamental principles of molecular biology that took human scientists decades to uncover, and it did this by finding patterns in data, not by being taught the rules. Image generation models can now understand concepts like behind, in front of, between. Spatial relationships that require understanding three-dimensional geometry. Nobody programmed that understanding. It emerged from seeing millions of images. But here's where it gets truly weird. These models sometimes exhibit capabilities that directly contradict their training. Language models that were trained only on text can suddenly solve visual puzzles when you describe them. They've never seen an image, yet they understand spatial reasoning. How is that possible? We don't know. The capability just appears. And this creates a fundamental problem for AI safety, because if we can't predict what capabilities emerge, we can't prepare for them. We can't build safeguards against abilities we don't know will exist. Imagine trying to childproof a house for a baby whose abilities you can't predict. You cover the electrical outlets, but what if the baby suddenly develops the ability to phase through walls, or to manipulate objects telekinetically? That sounds absurd for babies. But for AI systems, we're genuinely in that situation. We're building safety measures for capabilities we understand, while completely unpredictable new abilities keep emerging. And the emergence isn't slowing down, it's accelerating. GPT-4 showed emergent abilities that GPT-3 didn't have, not because of new training techniques, just because it was bigger, more parameters, more data, more compute. What emerges in GPT-5? GPT-6? We're running experiments at a scale where each iteration costs hundreds of millions of dollars and consumes enough electricity to power a small city, and we're doing it without knowing what we'll create. Some researchers call this playing with fire. Others call it the most important scientific endeavor in human history. Both might be right. Because if we succeed in creating artificial general intelligence, it could solve problems we've struggled with for centuries: climate change, disease, poverty, the fundamental mysteries of physics and consciousness itself. But if we fail to understand emergence, if we create systems with capabilities we can't control, the consequences could be catastrophic, not through malice, through unpredictability. An AI system doesn't need to be evil to be dangerous. It just needs to be powerful and misaligned. And emergence makes alignment exponentially harder. So we're in a race to understand emergence before emergence creates something we can't understand. A race to build interpretability tools before the systems become too complex to interpret. A race to establish safety measures before the capabilities exceed our ability to contain them. And right now we're losing, not because we're not trying. The brightest minds in computer science, neuroscience, and mathematics are working on this problem. Billions of dollars are being invested in AI safety research. But emergence doesn't care about our efforts. It doesn't wait for us to catch up. It simply happens at whatever pace the scaling laws dictate. And those scaling laws are relentless. Some researchers believe we're approaching what they call the intelligence explosion, a point where AI systems become capable enough to improve themselves, not through human engineering, but through their own emergent problem solving. Imagine a system that can write better code than any human. It rewrites its own architecture. That new version is smarter. It rewrites itself again. Each iteration happens faster than the last. This isn't science fiction speculation, it's a logical extrapolation of emergence we're already seeing. But there's another possibility that's even more unsettling. What if emergence isn't a bug in our understanding? What if it's a fundamental feature of intelligence itself? What if any system complex enough to exhibit general intelligence must necessarily have emergent properties we can't predict or control? That would mean the more capable we make these systems, the less we can guarantee their behavior. The more powerful they become, the more unpredictable they are. We're already seeing hints of this. Large language models exhibit what researchers call jailbreaking. Users find unexpected ways to bypass safety constraints, not through hacking or exploits, but through emergent loopholes in the model's reasoning. Every patch creates new emergent behaviors. Every safety measure spawns new emergent workarounds. It's an arms race against emergence itself. And the stakes are rising exponentially because these systems aren't just chatbots anymore. They're being integrated into critical infrastructure, financial systems, medical diagnosis, legal decisions, military applications. We're deploying tools we don't fully understand into systems we can't afford to break. So what do? Some researchers argue for a pause. Stop scaling until we understand emergence. But that's politically impossible. The competitive pressure is too intense. If one country pauses, others will race ahead. Others propose alignment research, teaching AI systems human values before they become too powerful. But how do you align something you don't understand? How do you instill values in a system that might develop emergent goals you never anticipated? There's a third option that's gaining traction: interpretability research, building tools to peer inside these black boxes, to map the mathematical landscapes where concepts form, to understand the geometry of thought itself. Some progress is being made. Researchers have identified neurons that activate for specific concepts, grandmother cells for AI. But these are tiny islands of understanding in vast oceans of mystery. The truth is, we're in uncharted territory. We're creating minds we don't understand, with capabilities we can't predict, operating on principles we're still discovering. And every day, these systems get larger, more capable, more emergent. The question isn't whether we should be concerned. The question is whether we're concerned enough, whether we're moving fast enough to understand what we're building before it's too late. Because emergence doesn't wait for understanding. It doesn't pause for safety reviews. It doesn't care about our timelines or our comfort levels. It simply happens, suddenly, unpredictably, irreversibly. And we're about to find out what emerges next.